I'm here with Gigi Karmous Edwards, a water hero and a leader in the important area of digital twin. You know, when I see what you're doing with Neome and digital twin, it's very exciting to get together with you and hear what's actually going on with you and all the impact that you're having. So it's great to have an opportunity to talk with you, Gigi.
Thank you. It's great to be here. And I wouldn't say that is me having an impact. I think the water sector as a whole is going through some interesting changes right now. It's very exciting to participate in this evolution.
Agree. So why don't you give us a little background on yourself and the work that you are doing right now?
Okay. So my background is really not in water at all. It's in data communications. I spent about 10 years in academic research on something called grid computing, which I would call that a precursor to cloud computing. It's really focused on the sharing of, these resources. I started reading a lot about the global water crisis, and I was surprised that we're not taking as good of care of our water resources as we should be. And I feel like there's enough technologies out there to help us do that more efficiently. And I made a career change and I decided to get into the water sector. My first job was director of technology at Census here in Raleigh, North Carolina. And there I started working on AMI data and putting together the analytics. Once we have this type of data from AMI, the automated meter infrastructure, where we can get hourly meter data rather than monthly meter data showing the consumption of the consumers. I think there is a world of opportunity that we can do with this type of data. And so that was my first, dipping of toe into the water sector. I then moved on to another company called Fathom. That was also a platform, a digital platform for the water sector, looking at AMI meter data and integrating other type of data like SCADA data. And then I moved on to Amman Advisors, where I was helping with really advice on digital technologies for the water sector. And as of the last 3 to 4 years, I've started my own independent consulting company, Karmous Edwards Consulting, where I work with utilities around the world. I work with technology companies on digital transformation and digital technology roadmap.
What motivates you?
What motivates me is knowing that if we utilize the technologies that exist out there today on some of our water infrastructure, I think we can eventually get to a point where we don't have the kind of leaks that we're seeing in today's water infrastructure due to the aging infrastructure. I think what excites me is when we can put all the pieces of the puzzle together and get an outcome that benefits, all citizens around the world in terms of really conserving our precious resource and taking the best care of it that we can. And I think with digital technologies, as I learned in my data communications day, you can start to understand exactly what's happening in that remote infrastructure. And once you understand exactly what's happening, you can resolve things before they turn into failures. And that is the promise of digital twins. So about 3 years ago, SWAN, the organization that is Smart Water Forum, came to me. Amir talked to me and said, how do we get more utilities involved with SWAN and digital technologies? And since the beginning, since the very first time I started working in water sector here at in Census, we had a research project with NC State University on a real-time simulation of hydraulic model using AMI data. And in essence, we didn't call it a digital twin, but that was a digital twin. So when Amir came to me and asked me some of these questions, I said, what the water sector really needs is a real working group that focuses on these concepts of digital twin, where we can all work collaboratively together. And that's universities, that's engineering consultants, water utilities, technology companies, research institutions, even government agencies work together and really try to first make digital twin concepts, bring the awareness of digital twin concepts. then also try to understand what are the challenges for utilities to migrate towards digital twin. And then collectively, again, together, we can start to think of ways that we can come up with best practices and make the entry point much, much easier for all utilities around the world, whether they're big, small, private, public. I think this is something that's going to be important for all utilities.
So give us an example of the impact that you've seen with digital twin.
So, digital twin concepts have been around for decades. It started off with rocket going on to the moon, and we talked about Houston, we have a problem. That was because they were running a digital twin of the launch of that rocket. And so, it's been in other sectors pretty consistently. And in manufacturing, it really has grown a lot. But in the water sector, we can take a look at examples like, for example, I always like to talk about Global Omnium in Valencia, Spain. They started on a digital transformation about 15 years ago or 16 years ago. And about 6 years ago, they started to develop a digital twin. And since they developed a digital twin of their water distribution, they've had very few, if any, outages because, when you have a digital twin, what you're doing is you're really running a simulation in near real time of what's really happening in the real physical world of your system. And you're getting input from real sensors, real meters into your simulation runs. And so that input data gives you an idea. And if you calibrate this simulation, this model, you're simulating what's happening out there in the physical world. If you can calibrate that, then now this gives you an idea of what's really happening in your system, because the model uses engineering knowledge and mathematical equations to calculate all different aspects of what's happening in the physical world. So let's say your pressure all of a sudden is constantly calculating pressure at all points of your water distribution because you've calibrated it. And it's going to detect any kind of changes that you're not expecting. So if the pressure automatically drops, it's going to give you some kind of an alert saying, hey, we're calculating that this pressure in this zone is lower than you would like it to be. So we're letting you know. Then you can start to take that insight. The operators can take that insight and go and investigate and hopefully find why that happened and resolve it. And hopefully that will prevent a real failure from happening, in the future. And what we're trying to say with digital twin is instead of flying blind in some cases, you're just gaining more and more understanding of what's really happening in your real world.
In your time in digital twin, what pleasant surprises have you had?
Okay, so like I had mentioned, when I first was working here at Census, we worked with NC State University, and there is Professor Kumar. He actually ran some simulations using City Logic at the time. It was a real-time hydraulic model based on EPANet. Jim Uber is the CEO of that company. It has since been acquired by Xylem. What Professor Kumar did is he actually showed the difference in the results and insights of, let's say, the chlorine concentration across the entire network when you're running the simulation of your water distribution based on assumptions of the consumption of the individual household and businesses for, let's say, the town of Cary. So then you use AMI data, which they were collecting using the census meters. And if you use that as input instead of the broad assumptions or average consumption, you then start to get more detailed into the behavior of your simulation. And you were able to see, like a step function in accuracy. You gain more accuracy in understanding what's happening. And so when you're letting your simulation model calculate the chlorine concentration based on an input, it now becomes more accurate because you're using more accurate input into your simulation. So that was a pleasant surprise. I'm also starting to see, as we gain accuracy at all levels, as we gain accuracy in asset data, like real detailed parameters and what our pump is really doing, what our valve is really doing, all of that information, as we feed more accuracy into the simulation, I believe we'll continue to take these step functions up in terms of accuracy of insights. And once you have accuracy of insights, I mean, it's limitless to all the benefits of a digital twin, because you'll know and gain knowledge of exactly what's happening, and you'll be able to prevent any kind of failure. You'll be alerted very, very quickly when something is a little bit out of whack.
So it would seem that digital twin is in the very near future of certainly water utilities, if not commercial users of water.
Yes, yes. I mean, I think we were seeing an increase in many more water utilities getting involved with the SWAN Digital Twin Working Group, for example. I remember when we started back in 2019, you saw some efforts mostly in Europe and Australia. I think the UK also has held a kind of a leadership role there, because the government, the UK government has mandated that all city infrastructure has to have digital twins. So they really were kind of pushed in that direction, and they show a lot of leadership that we're learning a great deal from. But I do see, like in the US, many more utilities get involved, have started to do proof of concepts, have started, work, going on the journey of digital twin. A digital twin is never, you never like have a digital twin. It's a continuous journey. You're constantly evolving, constantly adding more information. And again, it's important to say that a digital twin is not an application. It's a combination of many applications. You can see from the SWAN Working Group, we have published an architecture, and it shows that a digital twin is composed of many different sensors. How do you collect that data? How do you use the SCADA data, GIS data? All of these systems, you merge that information together. You use a model at the core, a model of whatever aspect of the system you're looking for, and run simulations. And that in its essence is a digital twin. It's not something you just pick off the shelf. You build it and you construct it and you constantly evolve it.
That's fascinating. So you established a relationship with Global Waterworks and all the water organizations out there. Why Global Waterworks?
Global Waterworks has been around for a while. I've known Mary for many, many years now. It's really at the heart of a lot of water concepts. You really, there's a lot of different water technology companies that are working with Global Waterworks, and you work also with a lot of utilities and thought leaders to really get the latest and greatest of what's happening in the global water sector. So I think it's an important platform that benefits the water sector greatly.
What does the future look like for you over the next 12 to 18 months, and as you do the work you're doing? And so what does it look like?
Well, I mean, I'm involved with a lot of, great thought leaders that I'm learning so much from on a few, papers. You're going to see a really fantastic paper coming out of the SWAN Holistic Architecture Working Group. That's going to be the second white paper coming out of the SWAN organization on digital twins. A lot of collaborative effort has gone into this, and led by Michael Carl and Shenzi Xu. It's going to be a very informative paper. WWA has now created a digital twin committee, continuing to work with NEOM. It's a futuristic city that's doing a lot of great advanced work in the water sector. So that's a very exciting thing that I'm working on. I'm also, I'm really interested in proof of concept. So anything bleeding edge, to do with component size, digital twin, you know, I've been working in the past with the city of Houston, with like, you know, we'll probably be continuing to work with them, and lots of other technology companies as well.
Well, it sounds like you have an exciting future. Gigi, thank you so much for taking this time with me today, and look forward to, you know, many other conversations in the future.
Me too. Thank you so much for the opportunity. Thanks,
Thanks,
Frank.
Gigi.
Take care. Bye.